Hi. One of the thesis when first building Zimmer Peacock as a company was to put all the tools in place so that if somebody, an entrepreneur or a company, a developer had an idea, that they could go from sort of idea to something like an MVP or minimally viable product very quickly. So that was one of the original sort of tenets of actually forming Zimmer Peacock. And so I'm going to do a summary of the technology stack that we now have in place, which I think really does actually accelerate the developments. Today I'll focus more on IVD, in vitro diagnostics, but similarly we could also apply this to wearables as well. So at Zimmer Peacock we have this catch or this phrase which is sensors to API, sensors to application programming interface. And as of today, Zimmer Peacock is an ISO 13485 contract developer and contract manufacturer of electrochemical biosensors and electrochemical IVDs. And the sensors to API means for us, and I will show a slide on this in a minute, that we are involved in the sensor. That can include the microfluidics, how to bring that sample to that sensor. It means we are involved in the electronics, how to drive that sensor, the kind of excitation protocols. It also means then we're involved in the connectivity, because everything we do is intrinsically connected to the cloud. And at Zimmer Peacock, we consider ourselves part of IoT, Internet of Things, which is, some people call it Industry 4.0 or Lab 4.0, depending on which industry you're in. But we're definitely the sensor electronics to cloud company, at which point then we process that data in the cloud and we allow other people, even in development, to be able to grab the data or the information, more importantly, using an API call upon us. So we intrinsically have our place in the sort of cloud connectivity landscape. We've taken our place around the table on that. So the technologies that we have in place, for example, if somebody comes to us and says, I want to do small molecules, and small molecules could be, ketones, lactate, glucose, for example, then Zimmer Peacock, we definitely have a long experience in doing small molecules. Sometimes we do it by enzymes, sometimes we do it by other catalytic means. If people come to us and ask us for ions, ions would be sodium, potassium, calcium, nitrate, ammonium, chloride, etc. Then we would definitely have often and pH as well as a classic ion. We'd have an ion selective electrode for that. If it's larger proteins or maybe viruses or bacteria, we might do what we call a binding assay, and we don't mind there whether we're using antibodies or aptamers, receptors, etc. So troponin I would be an example there of what we have. Now, in this particular video, what I'm going to what it actually shows you is that we have either the sensors on the shelf, or we're able to rapidly develop these sensors. When we rapidly develop them, we call it a proof of principle, and that's something that we just do as standard. But it's also worth saying that we have this whole technology platform which can involve. Here we're plugging in this piece of hardware, so that hardware lights up, and that meter, we kind of call it, it's really part of our ZP accelerator platform, but that meter can run, I would say, just about every electrochemical sensor I could imagine, because it's got all the voltammetric methods at its disposal. It has all the potentiometric methods at its disposal. It has all the amperometric methods at its disposal. So it's a very flexible instrument. And now you can see that the user here is actually using the phone to communicate with the meter. So you can intrinsically see that this is a platform for us. This is something that we do as part of development of an MVP, a minimally viable product. And so we have that app capability in-house. And there, when they were scanning the QR code, they were basically just doing a kind of a batch calibration. When you're manufacturing sensors, you can have batch-to-batch variation. And so they were just doing a sort of batch calibration. At this point now, they're actually pipetting the sample onto the sensor. Now, this could be a drop of blood. It could be urine. We're not talking about wearables today, so we're not going to talk about sweat and how we would deal with that. But at this point now, they're actually running the app, and so the app is telling the meter what to do. And the lovely thing about this meter is you don't need to develop it in order to get that MVP together. it exists. And because we're using the phone, it gives us a great screen, it gives us great connectivity, and we're able then to send that data onto the cloud. I just want to use some other images as well, just to give you a sense that it doesn't always have to be hand size. It can actually be almost thumb size. So here is an image of it's the same electronics, but in a very small form factor. And here we're actually, the potentiostat is actually plugged into the USB-C on an Android, so we're getting the power and the communications via the USB-C. And that really allows for a very small form factor electronics. Now, I have touched upon it a bit as well, but what makes it really accelerating at Zimmer Peacock is actually that we have a proprietary database. It's called Julie. That's with a D. It sort of talks to our part Norwegian heritage. But Julie, anyway, has an API capability. So the API capability allows us to send data, process that data, share that data, and more importantly as well, then it allows people to, like yourselves, to make a call upon that database using an API call. And so you can bring that data or that information into your cloud and give your sort of investors or your alpha beta testers your experience, rather than getting the ZP logos all over your data, let's say. So this kind of gives you a sense that we have the sensors, we have the platforms in terms of that hardware platforms, and we have somewhere to send the data, and you can get the data across in an API. Now, something that I'm just going to do the last slide upon is around embedded electronics, because we do get a lot of people who say, I want your sensors, but I want to develop your electronics. Electronics have become, I want to almost say, almost commoditized at this point. That at least the electronics that you need for electrochemical biosensors have been kind of very commoditized. So at ZP, what we're now able to say to people is, you can go to our website, you can tell us whether you're doing a glucose sensor, potassium sensor, or troponin I sensor. In the end, all this is doing is, by choosing the sensor, you're telling us what's the method of analysis, and that means it'll give us all the set points that we have to sort of program into it. So you tell us what kind of sensor. This is glucose, potassium, troponin I. I put troponin I up there as an example that we can deal with immunosensors, for example. At which point then, we're able to flash the memory of this electronics. And so rather than somebody, and now these electronics are small enough, they can either be used in a wearable, but we're actually expecting them to be kind of put embedded on top of a board that you have. So you'll have a system, let's say, where you've got your own electronics team, but that system might include some biosensors, glucose and lactate, and therefore then you can get these single boards off us, and you can get them in large quantities, and it really just skips this whole process of developing your own electronics, because you can just essentially buy skip the whole step and buy them in amounts. Like, I think on the website it talks about at least 100, 10,000 and 100,000 as well. So I'm going to summarize now, or say that thank you very much. But this video really was just about, at Zimmer Peacock, we do have sensors in place, hardware in place, the cloud in place, the ability to call upon that cloud using an API, and also skip this entire phase about custom electronics design or analog front end design. I think it's really become a commoditized industry now, and you can just, at least from Zimmer Peacock, get this from off the shelf. Okay, so I'll say thank you very much. If you've got any questions about Zimmer Peacock, please don't hesitate to reach out to us. Okay, thanks very much.